morning, good afternoon, good evening. I am Nick Chase from OpenStack Unlocked and Mirantis, and this is my co-host, John Jainschigg, also from Mirantis. And as you can probably tell, we are not in our normal remote state. We are, in fact, at the OpenStack Summit in Austin. It is day 4, as you will probably be able to tell by how punchy we are. And we are here with our special guest, who's going to introduce himself right now.
Sure. My name is Ivan Dwyer. I'm head of business development with Iron.io. Thanks for having me, guys.
It's definitely our pleasure.
And if you're wondering who this fine gentleman is, I came by myself to this meeting, but I did bring a sales guy to Austin with me, but he got the flu on day 1. So my honorary partner in crime is Mirantis jacket and hat, which I didn't get a jacket. I have a hat and the Ron Moss t-shirt, so I'm fully equipped, and I'm happy about that.
So we'll refer to him as Swaggy.
Swaggy. Oh, man, perfect.
Right. So, so we are here. With you and Swaggy. Okay.
Excellent.
So, at any rate, so now tell us what Iron.io does before we talk about anything else.
So Iron.io, we offer a container-based job processing platform. And essentially,
what does that mean?
In this world, that is the serverless computing trend that we've been hearing a lot about. It's breaking apart application components into containerized workloads that are microservices oriented, very loosely coupled, very nice packaged unit of work. And then we offer a queue-based service and a runtime that queues up those jobs based on some kind of event. So it could be a schedule, it could be an application webhook, it could be a sensor capture, it could be a system event. And it creates this pipeline of workload execution. And it's all Docker-based workflow and a container-based runtime.
So basically, Docker meets if this, then that.
Very similar, yeah. It's bring your own logic. So you write your code as a Docker image, upload it to Docker Hub or a private registry, and then when the event happens, it triggers the execution, and we just spin up and down containers, very short-lived containers, to execute the process, and then spin down. So it's a really good way to distribute workloads to process concurrently across a pool of available resources.
So what kind of granularity logic do you use to control spin up and spin down?
Sure. So a few things we do. We offer a number of base Docker images for language dependencies, and we use Alpine as our base layer, and we try to shrink the layers as much as possible. So we give that to our developers who will pick a Ruby stack, and then they'll write their code, import their dependencies, and then their actual job logic. Try to keep that as minimal as possible, because when the job gets placed into a message queue, and then the queue distributes that to what's available. So if I have a runtime, a cluster of Iron.io workers, I'm just pulling that job, spinning up a fresh container, grabbing the image, executing it, and destroying the container, and cleaning it all up. So we try to keep that as tight as possible. So small base layers, we use the queue to distribute that, and then just slice up whatever the resources are based on the footprint of the workload itself.
So then the queue is it's a pretty intelligent queue.
So we operate IronMQ, which is a standalone message queue service, but it also provides the backbone for the entire Iron platform. And it's the way to manage the life cycle of the entire workload. So if there's no runtime available, the job will sit in the queue. So if you think of like Internet of Things applications that are just generating a ridiculous amount of events, if you don't have enough runtime, you're going to lose a lot of data, lose a lot of processing. So if you put everything into a queue first, it's a good way to kind of buffer all that data and then distribute it across to what you have available to you.
So it assumes that you may be under-resourced at any given moment to handle surges.
Sure.
But manages surges.
But it manages it well, and also you can use the queue depth to spin up new infrastructure resources. So if you have really bursty workloads that are non-predictable in time, if the queue starts to really back up, you can attach some auto-scaling capabilities to that. And say if you have the servers, obviously, spin up some new ones or spin down if there's no load. So it acts as the kind of core middleware component to distribute the workloads and as kind of the lifecycle manager.
Is it the kind of I guess it depends very much on the specifics of every individual use case, but in general, was this written to be the kind of application that could easily coexist with more conventional and or other resource dependent kinds of applications on a single cloud?
Right. So if we go back to the origins of Iron.io, it was a consulting business, and we were building really large-scale applications. A lot of them were IoT use cases, but this was about 2009, 2010. People weren't talking about it then. And really, the need came to break apart independent workloads. This is before people were talking about microservices. Independent workloads that needed to scale outside of the core application. And so it was this very asynchronous kind of model of, okay, move this to the background, scale that out independently, because my main application, I can't replicate that across what I have available. So from that consulting business came the original products, which were the IronMQ and Iron Worker. And since that time, we have microservices, so that the notion of breaking apart independent workloads is familiar to a lot of people. We had our own container format that we had built based on LXC back in 2011, 2012, replaced that with Docker when that came out. And then these kind of event-driven patterns for, instead of this request response method of invocation, it's something happened and now I need to trigger the workload. All those things kind of came together at the right time for where we are now, and it all has kind of converged into this serverless model. But really what it is about independent scaling, background execution, event-driven computing.
Now, I noticed the air quotes.
Okay. Oh no, that's right. We're being filmed. We used to do a podcast. I can hear this all day.
But you can see the air quotes.
Sure.
See the air quotes.
Sure. Yes. So the way I say it is, serverless computing we know is impossible. Serverless architecture is somewhat misleading. It does not exist. There will be servers. That's always the case. Serverless, from my perspective, is about the developer experience. I'm able to build my applications, build my logic, and push it to a cloud environment, public or private, and have the proper DevOps kind of backing to know that I can spin up and down, provision resources, do some execution. Everything works nicely. And I don't have to be on call to kind of do the operations. So it's the DevOps kind of mentality of, I'm responsible for this. So if I push it to the cloud, I'm the one responsible as a developer. I think we're taking it one step further and saying, I'm the developer, I am responsible, but I don't need to do this kind of complex configuration. It's not about creating scripts that can, put together an environment for me that I know is, consistent across my dev to prod. I just write my code and then I offload it to some cloud, and that cloud is intelligent enough to do the configuration. And so it's, the infrastructure as code kind of mantra of DevOps. I kind of replaced that a little bit with infrastructure in response to code, but the code being the actual logic. And so if my logic says run this 1,000 times, the underlying system knows to do that. I don't have to provision VMs or containers to do so. The platform, which is kind of what we provide under the hood, knows that and is able to do that. And if it's running on OpenStack, it knows what's available within the OpenStack environment, and using the queue can kind of distribute that effectively.
So now, architecturally, how does this relate to OpenStack?
How it relates to OpenStack, and that's kind of why I'm here, is figuring a lot of that out. So the queue is a service, so the queue can be deployed into OpenStack as a service. That part is fairly straightforward. IronMQ is an alternative solution to RabbitMQ, so you could just put IronMQ and then use that to distribute across the compute. Where things get interesting, and this is what we're trying to kind of take it to the next level, is where that runtime exists and how that runtime interfaces with our service and the underlying compute capacity. So our runtime is this independent Docker container, which is an agent that is registered to a queue and registered to a Docker image registry. And it's just pulling and then executing. So I think we can deploy that as its service, same way we do the MQ service, tie the things together somehow. This is why I'm still figuring this out, but tie everything together and then understand the capacity and then execute containers with what's available. And that's where, I think Mirantis is helping us figure that out.
So talk a little bit about that.
Sure. So we're partners with Mirantis as of a couple weeks ago. John has been incredibly helpful in getting us the resources we need.
John actually has a day job. Sorry, go ahead.
It's a remote
Set us
job.
up with a lab
Which
environment.
is why I don't shave enough.
Yeah. We're being filmed, remember?
We always look like this
Yeah.
when we're being filmed.
And so we went through the process of building a Murano application package, and we did that for our message queue. And our message queue can be deployed as a single Docker container, and that's the most basic deployment possible. And we did that. So that was check that box before Summit. We got that working. So now we're putting all the heads together and figuring out, okay, now how can we really bring this into the OpenStack world beyond just this queue service. And some things that I think might be interesting, and we're still kind of figuring it out, but some of the telemetry components within OpenStack, if we can actually grab something from Ceilometer that executes a workflow, that can get really cool. Because then we're saying this is the equivalent service of AWS Lambda within OpenStack. And I think OpenStack, as a private cloud platform, we need to get to all the application workload possibilities. And it's not just about one type of enterprise workload. We've got microservices, we've got these serverless jobs. So to be able to do all of that under the OpenStack platform, I think is really important for the growth of the community and the ecosystem into the enterprise in this kind of new cloud native world.
I have to say, I'm very excited about this.
Good.
So I don't normally say that in the podcast. Sorry.
Sorry.
But I am.
We'll tame it down.
Okay.
It is Thursday. We've been here for 4 days.
I know, it's true.
How much it sounds like you would be a very useful thing for many enterprise software
You
packages
mean his
to know
product,
is
not
available.
him.
Yes,
Not me personally.
No, you
Nobody
personally
wants
too,
me.
but I
And definitely not Swaggy. Sorry, Swaggy.
But yeah.
Actually, I don't know about that.
I'm
Now
sorry.
we're talking.
You were saying, John, I'm sorry.
Don't be dissing on Swaggy. It is that a lot of for example, business process management, OSS/BSS in a carrier space,
Right.
would be happy to know that something like Iron.io existed
Yeah.
because it could use it possibly as a best of breed, kind of way of doing what
Right.
it's trying to do in a semi-crippled, we're not experts at this way already.
Exactly.
It might make lives easier.
Exactly.
What
Yeah.
kind of engagements do you have with the potentially enormous range of enterprise software
Sure.
makers that could use this?
Well, so being a development platform, we cover a pretty broad spectrum of customers. We have telco customers, using the queue service independently. We have a lot of, enterprises who are building out cloud native applications and kind of need containerized ways to power workloads. And then we have, born from the cloud type of companies who are, already up to speed on all this stuff and, just really need highly effective ways to distribute containerized workloads. Across that entire spectrum, we see a wide range of use cases, but they tend to fall into these asynchronous, workloads that have either like an ETL type pipeline where, kept capturing a ton of data from a variety of sources, need to put it into a queue, do some transformation processes on it, and deliver it to, some kind of data warehouse. We see a lot of those. We see a lot of, cron for the cloud. Cron jobs are still, make up a pretty good percentage of enterprise workloads, but man, it's easy to forget about your cron jobs. It's really easy. So having a service to kind of use the schedule as an event and then, be able to manage the life cycle of those, that's really, really a big one. And then batch processes, still we have a ton of batch processes. I think Gartner said that 70% of enterprise workloads are still done in batch. So, all of those kind of fit this pattern, but in a more cloud native kind of way.
So some of this is a hosted service.
It's a hosted service and it's a managed service that we can deploy.
Okay.
I would say aside from being a public hosted service in the OpenStack world, we could do a full stack deployment, but as I mentioned, that we have this independent runtime, and so if we can deploy that runtime by OpenStack, we can still manage all of the we call it the boring stuff, but it's the hard stuff. It's managing a queue service, it's hosting a dashboard, we've got analytics databases, all the stuff that it takes to power the system, and then deploy, here's a container, deploy this, that's your agent that's pulling the jobs and executing. That's our hybrid configuration, and I think in this scenario it makes the most sense, because it's really easy to just operate this independent runtime and say, I want to have 100 or 1,000 or 10,000 jobs containers available to me at any given time. So I just deploy it that way, and then use our API and our service to distribute the work.
Awesome.
Yeah.
Now these could be relatively complex jobs.
Yeah, or short-lived jobs, or very complex jobs. But the idea is that they have a start and a finish. Yeah.
Exactly. They don't run forever.
Right.
So you know, esoteric media processing, inline media processing, stuff like that.
Yeah.
You know, would be equally natural to IoT thing sends ping, do this now.
Yeah.
You know?
Yeah, exactly. Yeah, we have a healthcare company. I wish I could say which one. We're not quite there yet, but that does some really cool stuff on. They capture these DNA snapshots. They run like 20 different workloads on it in this pipeline, and it does all sorts of analytics on it. And each image they capture is like a terabyte. So they have just a ton of stuff, and it takes a few hours to get through the whole thing each time. But it's broken up into I think 20 different steps to get everything that needs to get through. And then we have some media companies who need to send a push notification to their millions of subscribers if a news alert happens. The code to send a push notification is very small, but to do it a million times in a very time-sensitive way, it's not a predictable time, is very challenging. But that's the kind of spectrum that we cover, which is pretty wide, I would say. So, the things we don't do, and we don't do 12-factor applications. Don't deploy a Rails stack into Iron IO and then run it in our way. That run asynchronous jobs is part of your Rails application in Iron. That's it makes more sense that way.
I got nothing.
Speechless.
Seems really useful. And the fact that you've solved the hybrid, the how do I call this and make it hybrid,
Yeah.
and thus get access to, mature and managed large hardware stack that I don't have to buy
Right.
thing
Right.
is to do this specific kind of workload processing is awesome. I mean, I would think that a lot of people, going back to my very first question, might want to try coexistence, but other people would automatically think, I'm going to have to create an availability zone for that, and I'm really going to have to give it its own hardware, and so having the option to sort of start in the cloud and move to the premise or stuff like that,
Right.
is
Like everything
pretty
else.
useful.
Yeah. That's the idea. This is workload portability, and I can choose where I want to run certain jobs, but I don't have to build a system in two different places. And that's where people I think freak out at the whole hybrid cloud situation. He says, man, I got to operate two very complex things. And if we can really break it down to the workloads, and that's what is portable, then it's an easier thing to swallow. And if we can really abstract away the complexities of operating these systems, and you guys do that great jobs at the OpenStack level, and we do it for what we do, and I think the ecosystem kind of forms the full stack, from private to public and hybrid, everything in between. At the end of the day, all the enterprises want to run their applications and they want to run their workloads, and that's what we're trying to accomplish. And I think it makes sense to, for all of us to kind of collaborate in that spirit.
Well, it will be fun going forward.
Absolutely, no question. Is there anything in particular you think that the OpenStack community needs to build?
Oof. Well, I'm still learning about the full OpenStack platform under the hood. So I'll leave that to the experts. I think. Yeah. Oh, you guys aren't experts? Oh man. What have we been talking about?
Find our presentation from Wednesday morning.
Oh yeah.
No, we know what we're doing.
I know. Yeah, well, I think one thing that I've learned, this is my first OpenStack summit, and I feel like there's still a lot of discussion around operating in the platform. I wanted to hear more about the applications people are running on OpenStack, and I still think it needs to get a little further along, and maybe I was in the wrong wrong rooms and wrong meetings, but I heard a lot of networking talk and, not enough application deployment.
Oh,
So,
you were in the wrong rooms.
Yeah.
You were totally in the wrong
Okay.
rooms, dude.
All right.
I track shared the cloud app talk, or track, so.
Yeah.
Yeah.
No, I'm sure, but yeah. So, I think we're trying to bring workloads to OpenStack, and that's what we're able to do, hopefully.
Great.
So, yeah.
Okay. So I asked this of all of our guests.
Uh-oh.
Name 2 people that you think we should have on the podcast.
Name 2 people. I would bring, let's see. I had a really good chat with, you probably already had him on the podcast, Eric Wright from VM Turbo.
No.
Super smart guy. He runs his own podcast, so maybe you could do a podcast share. And then who else? And I will promote our media sponsor that we had here, Alex Williams from the New Stack. He's fantastic, and I think I did a podcast with him earlier this week around serverless computing, and we had a really good talk. And I think what we're trying to do is cut through the buzzword and get to the meat of what's really happening. And we had a good talk, so sure.
Well, thank you so much.
Yeah, thanks guys. This was awesome.
And Swaggy.
Don't forget
And,
Swaggy.
thank you all so much for joining us. And if you're not at the summit, you've been getting some rest.
Yeah.
We'll see you next time.